Hello everyone, welcome to the Embedded System Practical series. Today we'll be doing the practical based on traffic signals. So this is the program. I will explain the program. It is a very easy program. Don't worry about this all the things which are written here, all the steps, the assembly language code. So in this particular practical we'll be using the LEDs as the signal lights. This LEDs, okay, is what I'm marking. These are the actually 8 LEDs are provided, and these are arranged in such a way that the top one is the red one, then the second one is the yellow, then green, then red, then yellow, then green. So this first 6 LEDs, they can be used as the signal lights. So we can assume that the first 3, red, yellow and green, they can be used for the north-south traffic, and next red, yellow and green, they can be used for the east-west traffic. So let us first understand the program, okay, then we will come to this. It is very easy program. So let us first understand the program. Now before going to the actual program, this LEDs which are given in that particular software. So in order to glow any of the LED, the input should be 0. Now input should be 0 in such a way that this is the most significant bit, okay, this gives the most significant bit, okay, then this is the least significant bit, okay. So suppose we want to glow, we want to make this as on and all as off, okay, all this should be off and this should be on. So the input should be 0 and then all as 1, okay, all the other 7 should be 1, okay. So this is what we have if we want to glow only this particular LED. So this should be 0, okay. So this gives the most significant bit. Now suppose we want to glow in this case, suppose we want to glow this particular LED, this one, okay. So if you want to glow this one, this LED, so in that case this all should be 1. So 1 1 1 1 1 1 1, so this is 7 ones and then finally a 0. So this 0 will, this is the least significant bit, and so on, okay. So we first understand this part, okay. Now in case of traffic lights, let us assume that we are just turning on the north-south traffic first. So this signal, the first 3 LEDs, they define the signal for the north-south traffic, and the next 3 they define for the east-west traffic. So this is north-south and this is east-west, okay. So let us assume that first we turn on of the north-south direction, and this is the input in case of assembly language, okay. Now this move P1, move port 1, okay. So because the LEDs, they are connected to the port 1, so we write this particular data in this B means binary. So let us see what we are getting with this particular thing. So we see we will have this, okay, this will be the output with this input, okay. So because this is 0, so this 0 will turn on this LED and it will become, it is red, because it is red, it will turn on and it gives red signal, and this one will ensure that this LED is glow and we get a green is turned on, okay. So whichever input is 0, it will be turned on. So as we can see here, this north south is given the red signal and east west is given a green signal, okay. So this is what we have with this particular input. Then there is a call BGD, means big delay, okay. I will explain this big delay, what is this big delay is. So we want to keep this status of signal as for some seconds, okay. So it should remain red and this should remain green for few, maybe like 30 seconds or 40 seconds. For that purpose we use this big delay. And after this what happens, then what we want is this green will turn yellow, okay. This is the second stage, we can say. So in that case what we have is, this is what we should have, okay. In the second part we should have this, okay. This red will remain red, but this green will turn yellow. For that case, with this is the input, which will give this, okay. So this 0 will ensure that this is actually, okay, this becomes this is glow, this remains red only, okay. This remains on either, and this one, it will turn off this particular LED, and this 0 will turn on this particular LED. So this becomes, so after green we should have, this is yellow, okay. And here after this we have a small SMT means small delay, because this yellow signal remains yellow for very few seconds, maybe 3 or 4 seconds. Okay, and then after this, what will happen is this green, this red will become green, and this yellow will turn to, okay, so this part, what we have afterwards is, this is what we have. Okay, this we should have this. Okay, and this is ensured by this. You can see this bit will, this 0 will turn on this particular LED, and this 0 will turn on this particular LED. Okay, so this is the signal in which, this is the case in which the north south will be given green signal and east west will be given the red signal. Okay, so then again we have a big delay, because this will remain on for few seconds, like 30-40 seconds. Okay, then after this what happens is, this north south traffic should turn yellow. Okay, and this is what we have. Okay, so this will turn yellow. Okay, so this particular input will ensure that this becomes yellow because of this, and this becomes red because of this. Okay, and this will remain for few seconds, very few seconds, so there's a small delay. Okay, so this is, we'll observe this. Okay, now at the start we have STR, so we want to run this particular loop infinitely, so therefore we have jump STR, so this will repeat itself again and again. Now let us come to the delay part. Okay, in the delay part, what we see, this is the big delay, this is marked in red. You can see BGD means big delay. So in that case, how delay is generated, this we are using a loop inside a loop. So we are just putting some number 0, a very big number, because we want to have a big delay. So we are putting a 0 AB, a big number in R0, and 06 in R1. We just continue decreasing R1. Okay, 0 AB times. So this is actually what we are doing, is we are generating a loop. Okay, we are generating a loop with this particular instructions. Okay, so this instruction will generate a very big loop. Okay, a very big delay will be generated by this, and this RET, it will ensure that, because this has been called, okay, this call will call this BGD. Okay, BGD delay, it will call this big BGD, and this return will ensure that the return program returns back to this original where it has left. Okay, and then for small SMD, so this is the SMD, this small delay. So in this case, as we can see, we are loading a very small number. Okay, this is a very small number we are loading in R0. Previously we had loaded 0 AB is a very big number, and 10 is a very small number. So because of this, it will generate a very small delay, and this RET will ensure that this particular loop returns back to the main program. Okay, so we can say that this is the main program. Okay, this is the main program, and as we know the concept of subroutines, so this is the main program. This part is the main program, and we are using two subroutines. This is one subroutine, the red one, and the violet. These are the two subroutines. So let us now run the program now. Okay, so we come to this particular program. Okay, this is the program. I have just copied it, so I will just assemble it. Okay, and I can run this program. So just see here what we are having: red, green. Okay, and then it becomes the yellow, and so this will run accordingly. Okay, you can just see this. Okay, so that's all for this particular program. Okay, thanks for watching.